Hi guys, this is Mrs. Allison. Today we are going to be looking at rates of change. Mostly this should be a fairly quick review, so it shouldn't take you too long today. We're going to look at two different types of rates of change: average rate of change, instantaneous rate of change. And those phrases get thrown around a fair amount in calculus, and so you need to feel very comfortable with what they represent. So let's go. Rate of change. Another name for rate of change is really just slope. So slope is rate of change. And you have been talking about rate of change or slope since Algebra 1. Think back to when that was. And average rate of change is what we're going to call our Algebra 1 slope. Oops, I didn't want it in that. Let's change it to a pencil. This will be our Algebra 1 slope. Okay, this is a slope of the secant line. So the slope of a secant line, and the way we find this slope should be almost secondhand by now, is if we have a function at b and we take away a function at a over b minus a, so the rate of change in y over change in x, that should be pretty familiar to you. The instantaneous rate of change, however, is our calculus slope. Okay, and the instantaneous rate of change is the slope of the tangent. So it's the slope of the tangent line. And the way that we find this is we find f prime at that point that we're trying to find. Okay. That should be pretty straightforward, so let's look at an example. Okay, we're going to let f of x equal x cubed plus 2x, and I have sketched a graph of this for you here. Okay, and it says, the first question says find the average rate of change, so make sure you're really watching. This says average rate of change, which we know means Algebra 1. I keep doing that. This is the Algebra 1. Rate of change from x equals 10 to x equals 30. Okay, so what does this look like? This looks like a straight line, the secant line between those 2 points. Okay, so if I'm going to find the slope of this, I am going to do f of 30 minus f of 10 over 30 minus 10. That should be pretty second nature at this point, and typing that in my calculator I get 1302. Okay, so how is that different than when I'm finding the instantaneous rate of change for when x equals 10? Well, the instantaneous rate of change is my calculus slope. Okay, and I need to then find the derivative of x, and the derivative of x, we're going to use the power rule. We get 3x squared plus 2. So I'm going to be calculating f prime at 10, and I get 302. This rate of change, if I were to draw it, is the tangent line right here at x equals 10. So that should be pretty straightforward. We will see you soon.